Hello everybody, welcome to my channel Programming in C with RSK, and I am Rajendra Kulkarni. Friends, in this video we are going to see how 2D arrays are declared, initialized and used in our programs. So let us start our video. Introduction to 2D arrays. How they are declared and initialized, that we will see in this slide. What is 2D array? Two-dimensional array is an array of one-dimensional arrays as its elements. So 2D array contains number of 1D arrays as its elements. How it is declared and initialized? Let us see in this int arr subscript, first subscript 3, second subscript 5, and then there is a sign of equal to, and within the two curly braces we mention the data that we want to assign to this 2D array. Here we have declared a array arr as a 2D array having dimensions 3 and 5. So it will contain 15 number of elements, 3 into 5, and accordingly we have inserted 15 int data types of constants within the curly braces, and after the closing curly brace there is a semicolon. So what this statement does, it declares the array of dimension 3 and 5 and also initialize it at the same time, declaration and initialization at the same time. As we have seen, two-dimensional array is an array of one-dimensional arrays. So this 147, 234, 411, 500 all separated by commas is the 0th element of the 2D array, which is a 1D array of 5 int constants. Then this is the element 1 and this is the element 2. So these 1D arrays, 3 in numbers, are the elements of 2D array arr. And what this 5 identifies, declares, tells the compiler that each element of the 1D array will be of dimension 5. So we have declared and initialized the array arr in the subscript 3 and second subscript 5 with constants of type int, because this array has been declared as a int array. Each constant which we want to assign to the each element of the array is written with commas in between, and the last element before which ends the initialization does not contain comma, no comma at the end. First subscript 3 tells the compiler that the array named arr will contain 3 numbers of 1D arrays as its elements. As we have seen here, element number 0 of the 2D array arr is a 1D array, element number 1, element number 2. Second subscript indicates that each 1D array is of 5 elements. Actually, we can visualize a 2D array as a table ARR, name of the array ARR. First subscript will be the rows of the array and second subscript will be the columns of the array. This is how we visualize a 2D array, a table of 5 columns or fields and rows of 3 1D arrays. So field 0, 1, 2, 3, 4, the 5 fields or 5 columns and 3 rows is a table which we can visualize as a 2D array. It is a just visualization where ARR 00 points to ARR 0 points to 0th element of the array, which is row 0, and the second 0 is the 0th element of 1D array, each 1D array, which is 147. ARR 24 points to 151. Row 2, column 4, which is 151. So we can just visualize, for the sake of visualization, that a 2D array can be looked at as a table. The first dimension will tell us the number of rows in that table, and the second dimension will tell us the number of columns of that table, and the rows and columns start from numbering numbering from 0. So row 0, column 0. In this slide we will be finding out what is the preprocessor command #define. Well, this slide doesn't have anything to do with 2D arrays, but using the macros we can simplify our programming. That is why, and I will be using the macros a lot of time in the further slides. So before going with further slide, let us understand what is preprocessor command #define. In this program there is a statement #define dim10. Dim, this is known as a macro definition, and #define is used to define the macros that we will be using in our program. Here dim stands for 10. So whenever dim will appear in our program, at the time of compilation, compiler will replace that dim with value 10. Similarly, we have defined another macro called name. This macro is defined as having character R. So whenever name will appear in our program, compiler before compiling will replace it with character R. Let us see a program using these two macros. A simple printf statement, %d printf %d dim. This dim, the value of dim assigned to it by the macro, should be displayed by this printf statement. Similarly, the character assigned to a macro called name will be displayed by this printf statement. And in this third printf statement, what we are getting is, we are running a for statement, a for loop, where I is equal to 0, I less than dim, I plus plus, and then this printf statement just displays the value of I in every iteration. Here we have used dim, which is a macro, and this dim will be replaced by number 10 when the program is compiled. So this loop effectively works till I is less than 10, and then when the I is less than 10 turns out to be false, the loop will terminate. So these are the outputs we are getting from this program. First printf %d dim will give us the display the value of dim as 10. The second printf statement, where we have used name name as the macro, this name will be replaced by r, and it is displayed here. Similarly, when this for loop runs, so I becomes 0 to 9, which is displayed here, and the loop terminates when I is more than 9. One thing to know is, as a general practice, macro names are always in capital letters while programming in C. It's not mandatory, but it is a general practice. So with this, in this slide, we are going to see how 2D array elements are accessed. A small program, we have defined dim as a macro with value 3. Then we have declared and initialized a 2D array named ARR of type int and having dimensions 2 as the number of 1D arrays which are the elements of this ARR, and dim, which is 3. Each 1D array is having dimensions 3. So each 1D array will contain 3 int constants as its elements. Now how we are accessing this array ARR? Through the loops I and for loops, two for loops, one with I is equal to 0 and nested another I loop of for loop with values j is equal to 0. What we get is, this printf statement displays the values of elements of ARR array. With this statement, printf %d ARR I j. So this is how we are accessing the 2D array elements using subscript notation. And then we are given another 3 printf statements. The first printf statement, address of ARR is equal to %u ARR. This statement will display the address of the 2D array ARR. The second printf statement will display the address of the element number 0 of the array ARR. Through this address of operator ampersand ARR 0 0. So this gives the address of the 0th 1D array, which is the 0th element of the array ARR. This ampersand ARR 10 will give us the address of the element number 1 of the array, which will be the 1D array consisting of values 6, 7 and 8. Here we are declared both the dimensions 2 and dim as that of array ARR, but we can skip to mention first dimension or the first subscript dimension when we declare the array and also initialize it at the time of declaration. Then here we have written the arrays in this fashion. This is just to enhance the reliability of how we are initializing the array. Even an array without first dimension and second dimension as 3, and then within the curly braces the values 1 2 3 6 7 8. This kind of declaration and initialization is also right. When the array initialized at the time of declaration, we can skip the mentioning the dimension in the first subscript. However, second dimension is always mandatory. Now what is the program output? What we have got is the values of the elements of the 2D array, then the address of 2D array, the base address, which is here 65514, and then the base address of the 0th element of this 2D array and the base address of the first element of the 2D array, which we have shown here as how it will be in the memory. Variable address ARR000 having an address 65514 contains value 1. ARR01 is located in the memory number 65516 with value 2. ARR02 located at 65518 location, value 3. Similarly, for the next 1D array, which is the next element of the 2D array, address 65520 will contain the values 6, which is a element number 0th element of the ARR10 array, and similarly 65522 and 65524 will hold the values 7 and 8. So what we understand from this is the elements of 2D array are located in contiguous memory locations. So here we can see from 65514 to 65524, these 10 or 12 memory locations has been assigned to the array ARR by the compiler. Now we have declared and initialized the 2D arrays up till now. Now we will see how a 2D array can be populated using a loop. So we have declared a 2D array ARR with dimensions 3 and dim, which is again 3. Since this array has only been declared and it has not been initialized, it is mandatory that both dimensions are mentioned when the array is declared. Then there is a for loop in which we are prompting the user to enter the values of for ARR, and those values are being assigned to ARR 0th element using the scanf statement. So what this for loop does, it prompts the user to enter the values which he wants to assign to the 0th element of the 2D array ARR, and whatever user enters is assigned by this scanf statement to the elements of 0th element of the 2D array, which is the 1D array of dimensions 3. So it will, when the user enters 3 values in this printf statement, the element number 0 of the array ARR will be initialized with the 3 int constants which we are entering through the keyboard. Similarly, the second element of the 2D array, which is another 1D array, its elements are getting populated by using the printf and scanf statement, and this ampersand ARR1 and subscript 0 will assign the entered values from the keyboard to the elements of 1D array, which is the element number 1 of the 2D array. Similarly, the second element of the 2D array is being assigned with values entered by the user through keyboard through this printf statement. And then we are with this for statement with this for loop, we are displaying the values entered by the user into this array. So for every prompt asking the user to enter the values, I have entered the values 1, 2, 3 up to 9, and these values are getting assigned to the elements of the array ARR, and this printf statement is displaying these values as 1, 2, 3, 4, 5, 6, 7, 8, 9. This is the screenshot of the output screen when I ran this program. Now we have seen up till now how 2D arrays are accessed using the subscript notation. In this slide we will come to know how the 2D array can be accessed using pointer notation. So we have declared a pointer float star x, and then declared and initialized the array ARR with values 1.1 to 10, and this array 2D array has 1D arrays having dimension 2, and since there are 10 constants we have assigned to this array, the compiler will know that there are 10 divided by 2, that means 5 1D arrays as the elements of this 2D array, and each 1D array is of dimension 2. So in effect what we have done is we have declared a array ARR with dimensions 5 and 2 and initialized it with the 10 float constants. Then we have given a loop in which we are displaying the addresses of 1D arrays which are the elements of this array ARR through this printf statement and this ampersand arr I 0. What this will do? It will display the addresses of 0th element of every 1D array which is a part of these 2D arrays. Then we are assigning the address of the 2D array ARR, starting address or the base address of the 2D array ARR to the pointer X. So in this statement, X is assigned with the address of 0th element of the array ARR. And this printf statement tells us the addresses of ARR array and the contents of the pointer X. Since X is assigned with the address of array, base address of array ARR, this should display the same value for both the printf statements. Then there is a for loop, and through this for loop what we are doing is we are displaying the address of pointer X in every iteration of the loop, and we are also displaying the values contained on at locations pointed to by X using the indirection operator star. And another way of accessing the values of 2D arrays using pointer notation is we simply find out what are the number of elements this array contains, and since this is a 2D array, it will contain the number of constants which are its elements, which is given by multiplication of both the dimensions. Here it is dim is 2 and there are 5 1D arrays, so j becomes 10, and then by simply using one single loop and assigning the address of the 0th element of the array ARR to pointer X, we are accessing the values which are stored in the array as its elements through this star of x plus I expression. As the i's value increments, the value add address operator will give us the values stored in the consecutive addresses which are being used in this for loop by the expression x plus I. So let us see what is the output of this program. It gives us the addresses of each 1D array, starting address or the base address of each 1D array which are the elements of the 2D array, and then we get the value stored at the elements of the 2D arrays by using pointer notation. So this is how we are declaring the array 2D array, initializing the 2D array, and also accessing the values of the 2D arrays using subscript notation and pointer notation. Now this diagram shows the how these elements are stored in the memory. As we have seen earlier, when a 2D array is used, compiler allocates consecutive or the contiguous memory locations to it. In this particular program, the 0th element of the array is located at 65484 location, and consecutive elements of the arrays are located in the contiguous memory locations. So this is all about the introductory part of the 2D array. Thank you very much for watching. Friends, I have uploaded up to more than 35 videos on my channel Programming in C with RSK. All these videos cover various topics of the C language. Please visit my channel, subscribe to my channel, share the videos, and my upcoming videos will be on preprocessor commands, files, storage classes, strings, 2D array, how they are used in functions, 3D arrays, structures, and many more topics. So please visit my channel, and thank you for watching.